Hello, everyone. And today we have Laurent with us, Laurent Lescop, who is an accomplished architect and professor at ENSA Nantes. He is also a leading researcher specializing in computational design, 3D modeling, so immersive technologies. So today he will be taking us through a workshop which will be about the simplifying complex geometries. So we'll be exploring particularly the work of Santiago Calatrava, as Laurent has mentioned before the workshop. So I think you'll be able to better explain it. So again, we welcome you to be a part of this BeeGraphy workshop series, which we are conducting under the BeeGraphy Design Award. And I'd like you all to check out the BeeGraphy Design Award as well. I hope those who are participating in the BeeGraphy Design Award, your progress is going good. If you have any queries, if you are facing any challenges, do join our Discord, and we are supporting everyone there. So without, I think, any further delay, learning, we can start with the workshop where Laurent will take us through some of these fascinating exercises today and how we'll be using algorithmic design in BeeGraphy.
Yep. Thank you, Abhishek. Laurent, we're really excited to have you. This is, I think, our first workshop. I mean, with BeeGraphy Online. Laurent started using BeeGraphy for education quite a while ago, while BeeGraphy was not yet as mature as now. And we're really grateful for all of the feedback from Laurent that helped us improve BeeGraphy and keep improving with all of the bug reports. And as Abhishek mentioned, I'll probably drop a link here to our Discord channel. So everyone is welcome to join. And in case you're experiencing any bugs or you're missing some features that we don't have yet, or maybe you can't find, don't hesitate to post it on our Discord server. We'll be really happy to hear that and help you get smoothen your experience with BeeGraphy. And without further delay, Laurent, the floor is yours. Thank you so much.
Thank you very much. Thank you very much for inviting me. Thank you very much for Yannick. Also, I must say, to follow my efforts on BeeGraphy, and it's true, I am a very early adopter, as I really fell in love with the platform, with the software, because I thought it was a very useful solution first for students and then for everyone who wants to get into the algorithm world. BeeGraphy is a very, very good platform for it. Just maybe as an introduction, I think I always get these questions from students. How important is it to learn those kind of techniques, these algorithmic techniques? It's always a question that comes back because it seems to be complicated, when you see all the wires and so on. And some students, for instance, and some professionals say it's easier maybe to use AutoCAD or other things. But there is a huge difference, and that's why for me it's important to dive in, because using AutoCAD, you've got some menus, you've got some tools that you got to use to do something. BeeGraphy is totally different. You have your mind, so you've got to follow your ideas. It's just the question of following the flow of your ideas. And so, in fact, you don't have to learn anything, I would say, because whenever you've got a question, when you say, okay, I need a segment, so there is a segment. I need a point. There is a point. There is no specific names or whatever if you say, I've got to divide, there is something which is called divide. So you just follow your ideas, and then you've got all the tools at your hands, and you assemble, and then you are telling the story. And I really like this idea of following the story and see how you can develop your ideas. And I was saying just before that what is also very interesting is to get the more dry, the more economical when developing something. And when I start to have a definition, I like to go back and start again just to see how much I can reduce the number of components and be as straight as possible. And it's very interesting to see others' definitions. How do you organize your space? How do you organize your thoughts, in fact? And this you can see. And the design is not only the result, that it's a story that you tell to others. And the definition itself is as interesting as what you get in the end. So that's why I think it's very important to learn that, to know how to, and to use it, because it's just a way of thinking. So for today, I will share. So maybe I will start with my blog. Okay. It's not to advertise myself, it's just to say that there are some resources. Whenever I try something, I learn something, I put it on my blog. So it's a reference. It's a reference, and it's also a kind of diary where I put everything. And there are a lot about BeeGraphy. There is a kind of starting exercise like this one, and many also tests that I've done. For instance, I like this one. The idea was how to create those kind of facade. So this is not what we are going to do today, just some ideas of what is possible. So you see, step by step, I try to see how to develop this kind of idea. So usually I start from an image or from an idea, and then I say, okay, how can I do that? And what I really appreciate with BeeGraphy, so you don't have windows and so on, because it wasn't the point at that time. Just it's I put some random textures, but in the end, what I really like with BeeGraphy is that we can have a kind of interface. I hope it's going to be okay. And then we can change. I think you know that, but you can really change inside a web page. So it's very interesting to demonstrate something or to explain or just to play around. And in architecture offices also, the question is who is using that and at what level. And usually you have some kind of super developers that know everything, and then you've got some users. And it's interesting to have a tool that allows also users to have hand on, and to be able to also to play with the tools. That's what BeeGraphy allows to. So this is one of these example. If you are very much beginner, because I don't know precisely if you're beginners or not, I've got this exercise to preach, which is very interesting just to start, because you've got a few elements to deal with, and it's always the same cycling. And from a point, you can create a very complex structure. Usually this is what I like to, starting from a very basic element, and then from that create a complex structure. On this one, we click. Okay, it's something also students are asking very often to have this kind of structure, and to know how they can stretch it, because there is a kind of magic using this kind of tools, because you can stretch, you can deform, and you still keep the shape. So maybe I can go to the end just to show the what can be done. And even solar paths. So I was interesting because I had a student from India who wanted to study an archaeological site, and we didn't have, you know, the proper solar path from the past. We just had tables, and so we tried to build something very specific, so we could recover the tables and the numbers, and then use BeeGraphy to build the solar path, so that it is also interesting for students, because it's not only using something, it's to know how does it work and what is a solar path, and what does it mean. So it's not that difficult, but in the end, you see, you've got this, so you can move the sun and find the right moment where you can study the where the sun is acting. This is the result. Okay, so for today, first we will do one first exercise, and if we have time, depending on the time we have, we will do a second one. So the first one that we will explore is this one, the Milwaukee Art Museum from Calatrava. We won't do the whole building, of course. So maybe you know that building. Maybe you saw that building in a film with robots. I think it's in how it's called. Transformers. In one Transformers film, they are using this museum as a set where the bad guy is hidden. So they are using this museum, but you don't see the superstructure, which is kind of shame. So this building has been done by Calatrava, and what is interesting, I will show you the film if it plays. There is this is the museum that I was talking about. And I was saying that it has been a set for that film, Transformers. You only see the lower part in the film, I think. And what is interesting, so maybe I can jump here without changing the page. Yeah, here. So when you go on site, this is what you see. See, the structure is opening. This is magic. I really love this project. It's pure Calatrava.
So when the museum is closed, it's like lowering the wings.
Yeah, they say it's a solar shade, but in fact, it doesn't really work as a solar shade. But yeah, it is like closed. And when we see the people walking, it means that it goes very fast to open up.
So like if you're walking nearby and see that the wings are up there, it means it's open, you can go.
Yeah, for sure. So we've got this other video, but you will have time to just watch other videos to see this building, which is really super interesting. And so the idea is, and what I found fascinating about this building, and that's why I've chosen it for this presentation, is you don't have any curves. There is no curves, so it's pure optical illusions to see curves, because it's only straight lines. So the idea is to see how can we replicate, or how can we design this this building, and how much difficult it could be to do that. In fact, it's not that difficult, and it allows us to go through several tools that are very interesting, and especially lists, of course, because you know that BeeGraphy, as every algorithmic tools, is based on lists and the understanding of lists. To start, then you've got your workspace here, and you've got your assets, what is published, shared, and so on, your favorites one, and then you can go to new model. So I will put the name, Milwaukee. Calatrava. And I will click on create. So sometimes we saw that sometimes it can be a bit slow to load the page. What I've noticed is then when you refresh the page, then it reloads more quickly. So whenever you see that it's a bit slow, depending on your connection, then you can refresh the page. So how it will going to work, this structure? In fact, so if I will go back to show you the results, and so it's going to be more visual to see what we are going to get as a result. You see, this is a very, very much simplified version of the museum, but it's exactly the way it works. So the idea is you've got the wings, and then you can open up the wings. So when it's closed, the museum is closed, it's going like that, a bit like that. This is the first picture we saw in the film. In the film, it is shot from this side, from the, what we could say, the back side, and then it opens up, and you've got exactly the same way of seeing that. Okay, so you've got the wings. I went a bit further, but and of course, as it is BeeGraphy, you can just regulate and change everything by changing the numbers. So the shape of the this initial structure, you can change the height. You can change. See if you notice that in a film it's more like that, or maybe higher. Of course, you can change everything because this is parametric and algorithmic design. The illusion is made by a combination of two shapes, which is an ellipse here and a straight line, and that's all. And this makes the illusion. So this is what we are going to do now. All right. So I will start by my first shape, which is going to be my ellipse. So I will find it in my primitives, put here. But now I will leave it as it is. It's okay. We can change, of course, the origin, the radius, and so on. This is what we can do afterwards. But for now, it's okay. So now from that, I've got to create a line from one tip of the ellipse and going straight up. I've got, of course, many possibilities to do it. I can use a 2 points line, or I can use a line, an SDL line to do that. I will take 2 points just to. So I think you know the difference between the SDL line. The SDL line, in fact, you need 1 point only, a vector to see in which direction your line is going to, and the length, which gives you the obviously the length of the line. By 2 points, what is interesting is that I will try to define my first point. By default, it is on the 0. And my second point will give me the height and the angle at the same time. So for my first point, I need it to be there, or there. I'm checking the drawing tools. Never mind. I won't use the drawing tools because I'm used to use Zoom and not Google Meet to do online courses. Sorry. So I need a point here on my curve. The easiest way to do that is to find my middle point, because this is a curve, and even for this kind of round curve, you've got a beginning and you've got an end. And my beginning should be here, and my end should be over there. So my beginning should be here, and it goes round, and my end is here. So if I choose to have the middle curve, I will try. So here, and it gives me that point. And this is good. This is exactly what I need for my first point. So I put it here. This I don't need anymore, so I can remove it. And then I will have to have the point, the second point. So I will go to vector, and I will click on construct point here. Okay, so I will connect there. So for now, my line is just lying on the ground. And what I need is a Z value. And I think it's going to be it. And no, and I need also the X value. So for that, there is a very nice tool that, of course, you'd be using all the time, is range input. So range input, this is where I'm going to put the numbers. So I will start with Z. So for instance, I will put as a maximum, I think I will put like a 20 just to start. I will see if it works or not. Steps, I don't need to be every 0.1. So for steps, I will put 1. And as Learning was saying, there is a possibility, this is very, very interesting in BeeGraphy, to change the name here. And so instead of leaving range input, I double click, and I will say this is my height. Okay. And what you've got to keep in mind is then you've got this interface where you can have a kind of public interface of your definition, and this is here. And you see that my box has the name window, and this is a kind of public. How do you call it? This space to demonstrate this.
The view mode or the demo mode?
Yeah, demo mode. So that's why it's very important to name all the box, because in the end, maybe we will have several, and it has to be clear. So we've got to name it properly. All right. So I'm gonna change the tab. No. Hopefully you remind me that the same thing. So the demo is here. So I've got my height here, and now I will just copy and paste, and this is very convenient to have this copy and paste there. Okay, so I will see. Go up to 10. And this is the base of my structure. A bit higher up. Okay, so this is going to be an inch. Don't remember the spellings.
TH. Like you missed a T before H. Now you missed G.
Yeah.
Yeah, you can write in French. By the end of the workshop, we will learn.
Oh, I got to practice. So, okay, this is the very first. This is the skeleton, in fact, of our structure, and everything is based on this skeleton. Okay, So now what we have to do is to connect this branch, the mass, to our ellipse from both sides. So this ellipse has to be divided into two. So it is here. There are many ways to do it, to divide the ellipse into two. I will use this explode, or shutter. I will just check whether it's easier to explode, to shutter. It's easier with a shutter. Explode, you don't really have the control. With shattering, that you can say precisely where you want to cut the curves. There are many ways to do it. You can have, I could have used a line to say, okay, I divide from this line. Shattering, what is interesting is that you just have to indicate 1 point or 2 points, and then it will work. So this I will suppress. There, I will connect my curve, and then I will have to know where I do the points that cuts. So for the moment, I don't have, I've got 1 point and I miss one here because I want those two halves here from one side and from the other side. So what I'm going to do is precisely or very closely the same thing. So I will take the endpoints here. I will connect my curve here. So now I've got 1 point. They are superposed, superimposed, the one and the two here, they are exactly at the same place. So what I can do is just connect this one, and then I will connect that one. Okay, and you know that to connect things, you just use Shift. And let's verify if it works or not. So here it's okay. I see I still have my curve, hopefully. Okay. But do I have two curves, two halves? Let's check it. So I will try this dispatch pattern. Dispatch is a very nice tool. By default, dispatch takes 1 out of 2. Okay. So as I've got only 2, I might have the first half here and the second half there. Let's try. Okay. So if I click here, you see in the menu, I've got the detail of what I've got inside. I could use also the debug tool just to check if it works. Okay, 1. And if I go here, up here, I can see I've got 1. Okay, so it shall be working. So let's see. So now I've got to, as I said, connect some points along this mass to the curve here. So let's drive from one side, and this is how we will check if the dispatch is totally working. So I go to tool, and then I will go to divide. Yeah. I will do divide by count, which is the easiest one. So I'll start with, what did I do? Start, yeah. I did it the easy way when I started the first time. So I connect my line. What I suggest when doing this kind of thing is to start with small numbers, and then you can increase the numbers. But if it works with a small number, then it should work with a higher number. But to visualize the result, the best is to start with small numbers. So I will do a range input. I didn't explain it, but what I do is I double click on the screen, and then I just do with this range input phrase because I know that, and with practice, you know that you don't have to go to the menus all the time because you will know that if you double click and you need a line, then you just type line, and so on and so forth. And it's also very interesting because sometimes you don't know if one tool is existing, and you say, oh, it would be nice if I would have something like, I don't know, a circle, and you can't find it, so you say, well, where is this circle? So you just double click and you type circle, and you will have all the list of circles. This is something I do very often. And I would say when I started that, I couldn't find ellipse. I don't know why, but I thought there must be one. So I started just to type ellipse, and then I found that there was one in the list. And then I discovered that I wasn't seeing properly, and it is here. So it's very, as I was saying, it's following the flow of your mind. So if you've got an idea, just double click, type what you want to have, and then hopefully you could find it. So this range, I would put division or number of I would say of bones in this structure. Okay, so it's not used to leave 0 because at least I need 1. So I will start with at least 2 even, and of course it has to be like that. Okay, so for my test I will put 6. I connect here. All right, so I need exactly the same division on my curve. So what I'm gonna do is to just copy that, and we put one of my curves, this one. Okay, it is from that side, and then I will create a line to connect here and there and there. We will see what is going on. So I put line. Okay, I connect my points there and there. So what is happening here? It happens often, and this is nice when you've got this kind of error. It seems to be twisted. There is one point that it doesn't like, so I've got to identify that point. It happens. So this is all about lists, and so removing one element. See if I can remove the first one, for instance. So we'll try to
remove by index. Yeah, the third one.
Oh yeah, yes. This is the one I was. It's going to be better. Yeah. Index. Yes, this is exactly what I was looking for. Up this one, and we will see if it works. And now it does. And so the reason why was because the first point was exactly on the same location than the first point of the curve was exactly at the same place of this first point of the line. So we could have a kind of no line. Sometimes it works, but there it does not. So this is better to remove the first point and then to carry on this way. Okay, so we've got this side already. Now we will have to do the same with the other side. What we saw is that it was like twisted. It's because there, if we number the points, we will have here number 1, number 2, number 2, number 3, number 3, and so on. But on the other side, so it goes 0, 1, 2, 3, 4, 5, 6. And on that side is going to be 0, 1, 2, 3, 4, 5, 6. And that's why, so as 1 is connecting to 1, 2 to 2, 3 to 3, and so on, So we will have to solve this problem, which is not a problem, in fact, which is very easy to solve. So I will, the same way, divide. I don't really have to copy and paste all that because I could connect all the lines and then redispatch. But maybe it's easier to start to have, you know, this to copy like that. So, again, I will show the error. So I connect this. Maybe I will do a remove also here, because I shall have exactly the same problem here. And if I create my line, so this goes here, goes here. You see, it's all twisted. So what I will do is simply to invert the curve, the line of the curve. And you've got a tool for that. It's flip. So we'll flip geometry. I'll take this one here, connect here, connect here, and voila. See, now it's working.
Can you maybe elaborate a bit, like why it was twisted in this case and not in the other case?
So I'm gonna see if I can draw, if I can use the board.
Abhishek, do you remember how to draw here in Google Meet? I think there was some tool. I can't remember how to.
Yeah, there is one.
Sorry, how to draw?
Yeah. So, so it's just a question of numbering. You know, this point is number 0. This point is number 1. That one is number 2, 3, 4, 5, and 6 in the end. On my line, this first point is number 0, 2, and this one is number 1, number 2, number 3, 4, 5, and 6 on the tip over there. So when you use line, in fact, what you have is the list of points there, and they are numbered 1, 2, 3, 4, 5, etc. And they're exactly the same, 0, 1, 2, 3. And when you use line, they connect 1 with 1, 2 with 2, and 3 with 3. So it's 1, 2 with 2, 3 with 3, 4 with 4. Okay, and the error that we had is because 0 is connected to 0, which is good, but it creates a 1-point line, and so the system doesn't accept it. Say no, you can have a 1-point line. So this is from this side, and now I will first I will try to erase. Okay, I will turn it this way, and I will unflip my geometry. So what is happening is I still have, you know, on this curve 1, 2, 3, and so on. But this, as my curve is turning this way, okay, and it goes this way. So the flow of numbers still is, before it was cut, it would have been 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And now it has been cut. So, but it's still turning the same way. So 0 is here, and 1 is here, and 2 is here, and 3 is here, 4, 5, 6. And when it connects, the one here on the straight line is trying to get the one on the curve. And the second, number 2, is trying to connect this one, and so on. So it is twisted. So what we do is to say, okay, we've got to reverse the flow of the curve. Instead of turning this way, it will turn this way. So for that, we do a flip. We flip the geometry. And doing that, 0 comes back here, and 1 here, and so on and so forth. And this is how it works now.
Yeah, thanks you, Laurent. I think now it's clear.
Yes, it's very important to know that, because sometimes you get stuck with those kind of errors, and you don't know how to untwist things. I'm sorry, Lenny, don't hit me. But is there a way to number the points? Not, not yet.
Let me check with my team.
So maybe in the next version there will be a way to number the points, so that we will see this very better. Okay, so we've got 6 divisions. We can increase it just to see if it works. Yes. So I put a maximum of 10, but let's put 30 for instance. I like to do that just to check if the system resists, how far it will resist, and when is it going to crash. So still you can see from here, you've got only straight lines, and you can see that very nice curve. This is what I love in this structure. Got a very nice geometric illusion. We go back to 10. So now what you can do is to create the walls. And before that, we will do something else, which is going to be organizing the space, because it comes to be a bit messy. So this is the creation of the mass, let's say so. So I just will make a group and put a name on it, or name it mass. Oops. Mass. Ellipse, I will leave it this way, and then it's going to be dispatch. Here we can have a group. That. And during the groups, it's also a way to, so it's like, for this one, I will put it step 2, to prepare the final. So this is dividing, and this is creating. So this skeleton. This I need it because it's going to be the number of bones. I will keep that in a group, saying preparing skeleton. Okay, and this is going to be so my bones. From here, what I can do is to create the walls. So I will do with a loft surface. Loft. This tool is very interesting tools, because it takes some lines, some curves, and from curves you've got a surface. So in this I can connect directly. What I like, you see this, I like two things in BeeGraphy, which is very, very nice for the interface. First is that, you know, you've got a kind of color code. So this yellow brownish color goes to what is the same color. What is number is blue, what is letter is green, not that green, but another green. And so you don't make mistakes, and you can have some clues how to connect things and what is connected to what. And something also that I like very much, I think it has been a very good idea in the development of BeeGraphy, is that when I click somewhere, you know, up it goes back to where it is in the definition. So it's very, very easy when it comes to be a bit complicated, and you just click and then you know precisely where it goes. So we will have to hide some objects here because we've got a lot of points, and so it makes things complicated. What we can do is to select, for instance, a group, and I go left click, I put hide. Okay, so this is good enough for me to carry on. Okay, so this is going to be like the walls. Let's call it the walls. Here we'll make a group. You remember that we've got to open up the wings. So for that, we need a rotation. So we will go into new problems using rotations because we will need, we'll see if it works or not, because first I had some problems, but maybe today I won't have. So rotations, rotation, if I don't know precisely where it is, so I just click like rotate. I've got many, so it's not vector, it's not plane, it's going to be rotate here. Okay, so what do I need for that? I need an angle, and it's in radian. I need a center, and I need a vector. All right, so let's start with a vector. It has to rotate along the spine. Yes, I call it mass, but in fact, it's not a mass, it's a spine. I will change this here. Spine, because it's more spine than a mass. A spine, this is my spine. Okay, so it had to rotate along this spine. As I need a vector, so I need to create a vector using this spine. What I can do is, so I've got this line, which is my spine, and this line, what I'm going to do is to get 2 points out of it. Okay, the endpoints here. So I've got this one here and that one here. And from those 2 points, I'm going to just create a vector from 2 points. And this is something I've got here. Vector by 2 points. So I put it here, right? The first point here, I think the orientation, if I've got some errors, it's because I didn't check if the vector is pointing up or down. We will see if it works. If it doesn't work, I just have to switch the points here. So great. I've got my vector here. So just have to connect it. The center points, is it easy? Center points are my points. And luckily, we've got them here. So which one are they? Let's select them. No, so it's not that list. It's this one. Okay. Those are my points. Those are my center points. Okay. Click here, and then I will hide it again. And my lines, they are those ones. So I will start from one side, and then I will do the same for the other side. This is my geometry that I put here. Okay. It seems to be not too bad. We'll see. So my angle is in radians. So I'm not very comfortable with radians. So what I do is to convert degrees to radians so that I can think in degrees, and then I can translate it into radians. If you are comfortable into radians, that it doesn't, it's not an issue. So I will have my famous range input here. Okay, this is going to be our angle. And then here I would try to have this, so every 1 degree is quite enough. And I try to go from 0 to 90 just to see. Okay, so numbers to number right here, radian to here. What is going to okay. Maybe it's not the right curves. Let's try with this side. Oh yeah, that's it. Okay, it works. Thing is, you see, the last one is not very nice. So maybe I can remove the last one because I don't like this angle. I don't know why it goes this way, but it's not very nice. So we will see if we keep it or not. Maybe, oh yeah. We'll see, but maybe this one is gonna not last too long. So I will do the same here, rotate. I can copy, you know, when you start, and even for me, when I just try to create a definition at first, I just copy paste, and then I try to reduce as much as I can. But for now, we're not in this process of reducing everything. So we will try to keep a bit more components, and to see precisely what is going on. So I've got this angle. What I want is when I manipulate this, it affects both sides. So this side is not working. Just what I need to have, okay, just in case, yeah. Instead of having the angle that way, it has to be negative. So I will multiply by -1. So I will input a constant, which is going to be -1, and then multiply. This, I will find it here in maths. Okay. And this radian results, I think, is going to work. Oops. There. And which slide is it? This one is working. The other one. Oh yeah, because this one. And this one. Okay. So this is when it comes to be, you know, this spaghetti plate. So let's check the connections. The first, so the lines on that side, you see, is going here to rotate. So if we sum up, the rotation that we have on that side is just direct, positive, radiant. You remember that we have the vector here. So the vector is connecting both boxes here. The center is the same as well. The geometry is lines from one side and lines from the other side. And on the right side, we have to have a negative value. So I did a multiplication, and then it's connected to my angle here. So instead of having plus 90 degrees. I've got minus 90 degrees.
Laurent, just probably you are not aware, but like in Grasshopper, there is a negative, the node. In
Yeah.
BeeGraphy, it's just called opposite because we
Uh-huh.
thought, well, it makes it not
Is it
always
in,
negative.
is it
You
in
should,
math?
I'm not sure whether it is in math, but you can type,
Opposite.
even
Oh,
if
yeah.
you type negative, it will bring it.
Okay, so let's try. So I put my number here.
We just thought it's not.
Yeah.
Yeah.
Thank you, because I didn't know it. So it works. It works perfect. So we can remove that and save more memory, because as far as I remember, you explained me the more component we put on the definition, the more memory it takes, of course, and then it affects on the fluidity of the work. Kind of tricky part now is how to add volume to those bones. There are many possibilities. If you are lazy, you can go to tools and then you go to tube. And we open up this. You can go to tube, pipe, and then you put here range value, input range. Here I will set it very small because I think it is going to be small. There. The maximum is going to be 1 maximum. Okay, I put that here. I try to increase it a bit. This is a way to have some volumes. This is very lazy and this is not very nice. Let's say, okay, for if we really start and we don't have a lot of time, it could be a way. So to make it nicer, I can increase the number of where is it? The number of bones here. So that is going to be dense, more dense. But you can see this way that it's only straight lines, and there is no curves, and it really works for this optical illusion. Let's say now that we are not lazy and we don't want to have tubes, but we would have rather have some flat elements. It's going to be a bit more tricky, but it's interesting just to explore lists again, because in algorithmic design, lists is everything. If you do understand this concept of list, which is here, so then you are ready to do anything, everything, because it's only how you organize things with lists. It's not complicated, but can be sometimes a bit tricky. So what I would like to have is to have a kind of, this flat thing, something squarey. I can do that also by using a square. So a square that could be extrude along those lines. This is a way. It takes time. For me, it's a bit tedious work to do that. I would like to test something else. So let's try. I'm not sure to succeed. What I want to do, so I will do a small drawing here. What I would like to do is to take this and that and fill it with a what's it name? With a loft surface. So then I will take that one and that one. I loft it, and then afterwards maybe I will take. I don't know if it's possible to have a different color. Yeah, I will try get a different color. Then I would like to take this one again and that one and fill it, so that I will have this structure to be seen. Okay, so let's try that. What I need to separate those elements. So I take my list, and in my list, I can do some kind of sublists. To do that, I will partition my list. Okay, so let's try. So I take this, and the size is going to be, so I will take a constant. I need two elements. Right here, and then I got an error with 2. Okay. So I've got sublist here. I will try if it works or not. So I will take the loft curves. Oh yeah, it works. So you see, I took the subdivided my list in groups of 2. So I take those 2, then I jump to the next one, 2, next one, and jump to the next one, 2, 2, 2, and so on. Then I have to do the same to fill up this space here in between. So let's try. What I can do is to say, instead of starting from this one, maybe I can start from that one, the next one. To do that, I go to list. I will go to shift list. Shift list is so usually I type it, so to remember where it is.
I think you can type it directly.
Yeah, just I wanted to find it in the menu. Is there a way to find it back in the menu when you've got one component? List order. Shift. Yeah, this is. No, I do remember that with learning we did search an icon, or he asked me about the icon of shift list. I think I said this one is very good.
That's quite dense.
Okay, so I will connect my shift list here, and then I can copy paste this. Okay, and we will see if it works. Yes. This is nice. I'll try to rearrange. So shift list is very nice for that.
Yeah.
You see. But I've got one here which I don't want that appeared. So it appeared in this collection. So I will have to remove it. So let's try to see if I can remove it, because this is nice. And if I increase the number of bones, it should follow. Yeah, without breaking the structure. So it does work. Yeah. Oops. It doesn't work with that odd number. It has to be this. So we will try to remove by index the way we were trying before. Hopefully, it's not a number -1. I hope so. So we will try remove by index. This is it. List there. And let's try to have this number. So where are you hiding, you? Number here.
No, not that one. Probably you need to reverse.
No, but what is happening, and this is this is a very interesting error. I mean, it's not an error, but what is happening here? It's I do remember when I started Grasshopper a few years ago, I had to be stuck with these problems at the beginning. It was
Oh,
like,
it's a data trick.
oh, it's not working, and so on. It's just a question of, how is organized your list. And so you've got dots here, meaning that, in fact, it's this list. I mean, everything which is inside this collection of objects is made of sublists. Maybe we will have to explain that for a certain time, because list, sublists, and so on is really the essence of it, and it's quite complicated. Meaning that, in fact, you can imagine that you've got a box, and maybe I can draw that because it's so important. It's everything is it's here. So imagine when you've got a collection like this one, you've got all your surfaces in that one. But in fact, the way they are orders is like if you had one box, which is this one, and inside that box, you've got sub boxes. Okay. Like that. But many, many boxes. And each surface is in one box. Okay. This is very, very important to understand. Very, very important. So when I say here that I want the number 2 or number 3 or whatever, it doesn't make any sense because in each box, I've got only one object. So it tells me, why do you try to get the number 2, the object number 2, as in your boxes, you've got only one object. And so, okay, so how can I solve it? So in reality, if I want to choose because it's always ordered, it's as it is list. So you always have an order. It's always really well said. So in reality, if I've got this problem and I say, okay, I would like to have the number 3 in this collection, and but I can't do it because it's only one object in each box. So in each box, I don't have number 3 because it's only number 1. So what I would like in reality is to say, okay, instead of having sub boxes or boxes into my big box, I will take every one object and put it directly in the box. You see? So that I will have only one box and all my objects will be there. And then I can say, okay, I can take the number 3, which is, sorry for the very poor drawing, but I'm using the mouse. I don't know if it's clear. I don't know if I'm clear in my explanations, but it has to be so. So if I sum up, thank you, Nick. In this case, and I can say it because I've got dots, this kind of lines. I've got a big box and small boxes inside, and in those small boxes, I've got a limit my object, and in this situation, I've got only one object. And what I want is to just say, okay, let's take another box, and everything I will put here and there in the sandbox, so that now I will have all my objects and I can number, and I can take the number 1 and number 3. So maybe I'm not a good teacher because I'm using boxes to explain this, but in the menus, it's not boxes, it's tree. The idea should be the same. But let's translate boxes to trees. Anyway, So what you've got to remember is this operation of putting all those sub boxes into one. It is called flatten tree. This is what we're going to do. So maybe it has to be refreshed. Okay. Whenever it seems to be stuck, we just have to refresh. So I take this tree, this branch, and now I put it back here. And you see that the shape of the line has changed. And now everything is in the same box. And now I can just look for which number is this one. Explore it. Where are you? So this one is number 9. There is no 10. This is strange. So this one has been removed. We see there is one. So we're going to hide this one too, because it's going to be easier to trace.
I think after shift list, you can probably remove the last or the first one. What do you do?
You mean?
You did it shift list, and then the last one became the first, or the opposite?
Oh yeah. Yeah. Okay. Yeah, I've got to identify this very last one. Maybe I can go into list index. Here. We hide. So this is number 4, 3, 2, 1, 0, -1. And -1 is working. And this is -2, so -2 should be 7, 8. Okay. So button 3 locked. This is hidden. Okay. Shift. Yeah. Remove.
Pay attention that list item inputs shifted list, while
yeah.
remove by index, it's not a shifted list yet.
Yeah. So okay, I've got it. It is gone. This one. It was number 9. So it's how we can explore. And what happened is that other items were visible. So that's why, I can as it was visible, I thought it was erased, but in fact it was still visible by the previous component, which was here. Okay, so this is okay, it works, and oops, and this is it.
Maybe you can remove shift list. That's too.
Yes. Okay, so this is it. Wonderful. Okay, so this is my one side, and we can do the same on the other side. And it's, I don't know. I would see if it's just by copy paste, if it works. Let's check. Sometimes when trying to save time, in fact, it doesn't work, and it's more work to repair the errors. No. Okay. Very good. What do you think? We've got it, and it works. So let's check. Here, is it opening up? Yes, it does. It is working. Calatrava would be proud of us. I don't know. I hope so. Number of bones. They have got 20, so it has to be not an odd number, because if it's odd, it's not working. I got an issue. 60. Maybe it has to be refreshed, but it does work. Okay, and now if we go back to change these, okay, it follows. This works. I think there is a building which is very close to that one in Barcelona, like Calatrava too. I've got a strange line here. I don't know. Maybe it's because it's not refreshed. So sometimes when it's not refreshed, we've got some strange things appearing, but doesn't change. This we can increase.
Can you hover over that line? Maybe you can click on it and we'll see where it's coming from. No.
No, I'll try to refresh. Maybe by refreshing, we will have it. No?
That's still there.
Oh, it's a vector. It's the vector line. That's why. So I can hide this vector. Okay. So the vector line. So this is interesting because it can really be form finding from that. You see, you can have very different shapes. And this is where those kind of tools are very powerful, because trying to explore those shapes is quite difficult in reality. Imagine that you've got interns and you tell them to build as many models as possible to find the right shape. But there, you just have to explore, and it's done.
Okay. If this is over, maybe you can show the demo mode.
Oh yeah, but I didn't hide everything. So if I go to demo,
So
Is it
it's just 4 parameters.
Yeah, only four parameters, and it's enough to have everything and to explore it. And the wings. Bones. What I don't have right here is I put a number to remove, this extra surface that I had. I should have something like the last one or before the last one. This is something that can be added afterwards. Is there a way to have a kind of rendering in demo mode?
You need to change it in the editor mode first, I think.
Uh-huh.
But then you also need to apply material, I think. You want to change the colors, or you just wanted
No,
to
just I wanted to see the shadows on the
Ah.
ground. So I like that. Yeah. So this is the definition that we can have for this museum. I like this example because you see we had to go through lists. We had to go through transformations like rotations. And it has a very nice optical illusion where we can imagine that we've got curves, in fact we don't have, and it's only straight lines. So this is nice to have this. And we don't use a lot of tools, so that we can say with the minimum of tools and transformations, we can have great results.
I think Sagar liked the idea of changing the height. When you're changing the height, it was folding and unfolding there. So Sagar, I think, liked the idea. That's what he was wondering about, whether we can animate it or not.
Yeah, it was my question, and we talked about it, animating, having the possibility to animate the definition, but maybe it's further developments, right, to be able to animate.
Yes, in fact, I don't think it should be like it should be probably quite easy. The only reason we were not doing it is we wanted to introduce a smart approach of animating it so that the computer wouldn't have to re-render the same thing multiple times.
Yeah.
Regarding like fixing the tail, I think we could have added like one more point in the end, like evaluate curve and use parameter like 0.001 for both the spinal curve and the splits of the ellipse.
Yeah.
Yeah, splitting the ellipse would have been better, I think.
Yeah, because I need 3 points, in fact, or get that point, that one that I have, and that one. Yeah, and I can feel it.
Like because the last point is the first point, it wouldn't loft there. I guess it wants a curve, it can't loft. Or can it? Is there a way to loft to a point?
I'm not sure.
I don't think it will work because one point is common over there.
Yeah, that's right. Hmm. No,
But
maybe.
anyway, I think this is what the actual model is also like. I mean, it doesn't close completely. There is a gap.
What do you think of it? Trying to fill this gap. I think there are many possibilities, but I've got to figure out the best way and the easiest way to do that. I was
I feel
checking.
initially splitting the curve. I mean, at the end and in the beginning as well. If you split the curve, have two curves, separate curves, and then try to, I mean, loft from there, that would have worked better instead
Yeah.
of having one single ellipse.
Yeah, you're right. Yeah, you're right. So not to have this common point here, because if we've got, I don't know if you see what I'm pointing at, but the only problem is that we have this common point here, and it's and so if we do not have, or if it's if we can create, but it's not difficult. I mean, it's just a way of thinking this to in the process to have two separate points, and then it will work. We will have the filling of the gap. Maybe a very tiny hole, but in the end, it would work.
Yeah, I just checked the original. Indeed, it's not going till the end. So in detail.
No. No, I think he had the same problem.
But yeah, I think it came out nice. So I believe if anyone has any question, they can ask. And we can also demonstrate probably apply material node.
Yeah.
Like.
So the glass pavilion is a bit harder and longer, but maybe I can show and explain how does it work. So yes, sometimes I forgot that it's not necessary to think of saving, because it's save is all the way through, so it's very comfortable for that. So the Bruno Taut Pavilion, this is something which is famous. I will find the original project.
When I first heard about Bruno Taut, his name or his last name sounds French, but it's German, right?
It's German, yeah, from the Bauhaus. Glass Pavilion. Right, so this is the original project, and the roof is very, very impressive.
So each piece of glass is actually flat, right?
Yes, and this is the point. It has to be flat, and the question is how can we get this this drawing like a spiral, but with glass slates like that. It has to be flat. It has to be regular. And this is the point, how to do it and how to get this curve and how to get this shape. So I scratched my head a long time before doing that. I can confess that I found the solution using SketchUp, in fact, the first time. But then I really wanted to have it using BeeGraphy. And this is the so this is the end result. Every piece is flat here, so it does work.
I remember when you started doing this pavilion back then, before we had data trees, and it was quite complicated to do that, but you still found a way out of it.
Yeah, I've got many attempts before, and then data trees was really something helpful to do it. So what I'm going to do is to hide that. The starting point is with a basic geometry. So I will start with a, so it has 10 sides. So I need a polygon with 10 sides. Take polygon here. Origin, I let it at 0, count. So I will put a range output. The range input. Is there a possibility just to double click, for instance, here and change the value directly, or?
Pardon, get.
Do you know if
what was the question again?
it's just, I think there is no possibilities.
You can do it in the node there itself. Just hover over 6.
You want to change the number? Or
yeah, without putting anything, without connecting.
You can do it. Just go to the right part. A little bit.
Slightly above.
Oh, yeah. Very good. Okay. So every day is a new learning. Oh yeah, very good.
Yeah, instead of number const, in many cases, you can just change the default value right in the node.
Yeah, this is what is very nice with BeeGraphy, so that you can do that. You can change the names and so on. When teaching, sometimes it's not recommended to change the names, because if I put like decagon or something like that, the students, lazy students, they will try to search, because if they sleep for a certain moment and then they wake up and they see decagon here, they will say, oh, this is a new tool. We search for it, I didn't find it. So sometimes I leave the original names and original numbers, and then I explain that everything can be changed. But I like it here. So 10. 10. Okay. From that, so the idea is, which is quite simple, but the idea is to have a triangle out of those lines. So what I can do is to explode here. I will explode the curves. Okay. By doing that, I've got segments here. I've got my curves and my points. And now, so I should have 10 curves. Yeah. And check if I got my 10 curves. Yes, I've got 10 from 0 to 9. So this is 10. And then I will build some triangles out of each curve. Could be tricky. What I've found, just to have more possibilities to change the shape is to get the middle point from each curve, and then I will raise up the middle point. So the beginning is a bit tedious, but it works. So I move that vector, it has to be vector z here. And as I can have the length of my curves, so I can use the length, or just I can put a number. So I will go to range input here, number. Okay. So this is going to be my first triangles. This is kind of research before, because it could be equilateral, but I keep the possibility just to search the perfect shape. Okay, so then I need to have lines to create my triangles. So I will create some lines, and the lines are going to be from this point, the tip of the triangle, and from those ones. So let's try. I will try something. I didn't do it this way the last time. I will try to have a dispatch put here. It's not working. Not what I want. Because I wanted to. Yes, I know why. Because the first, yeah, I know why. Because I've got several times the same point is overlapping. So it's I should have 10, 20 points at that. I think I got more than 20. So I got less than 20. So I won't do it this way. Better, the safer, not better, but safer way to do that is going to have endpoints on the curve. Here. Okay, one here. Okay, this works. And then a second line. And is it going to be this one? Yeah. So here I've got my first triangles. And now from this is where we see it's not that obvious to do this geometry. Then I can have a line because I will draw what I would like to have, and how does it work with drawing. Just to explain what I'm trying to do. So I've got one triangle, which is here, and this is the base of it. And if we go back to the example, we will see, okay, and this is this line here. This is what I've done here. Okay. Trick is, this is flat here, and it is connected. And this is the trick. So this one is flat and is perfectly vertical. So this is what we've got, this line. And the second line is flat, but is not vertical. And this is where it comes to be complicated. So this is what we are going to solve. Okay, so this is my first that I was drawing. So what I need now is to create this next line here, but I can't do right away. I've got to do it in 2 steps. So what I'm going to do is first to create this, and then I will do a symmetry to create it here, and then to have the flat panel. And this is the trick, because doing this symmetry, what happens is that this triangle is not in the same plane. And this is we can say a flat plane, but this one is not in a flat plane. It's a bit tilted. So when I do the symmetry, then I will have the plate which is going to be tilted and starts the curves. And this is all the trick. So when I build all those like that, then I will start again creating this triangle, and the plane here is not going to be exactly the same. This is more tilted, and I will then create another one, and step by step, this one, it will make the dome. And this is it. And but so in theory is very easy. Practically speaking, it's a bit less easy. I don't know if it's clear enough what I was saying, but this is the way. So first I've got my triangle here. So I need to create another one, which I'm going to do. So from this list, I will create a polyline. Points. Here.
By the way, to make it easy, you don't have to click from the edge to edge. You can click in the middle of the port and drag it to the middle, and the button is quite big, so it's difficult to miss.
Okay. Okay. So now I've got my new polyline here, and it has to be closed. Okay. So I'll click Boolean close. It has to be explode for the same reason from the first one. So I will explode. Here. And now this point has to be symmetrical from that axis up here. And this is the tedious part. Sorry. Maybe it's not a very easy example, but I think it is interesting to, when you get the final result, it's very interesting. So what I need is, from that curve, I need the midpoint, obviously. So the midpoint is going to be here. All right. Then I need, I think I will need, do I need a vector? Yeah, because yes, this is a way to do it, maybe not to, yes, I will do it this way. Using a vector is going to be easier. Even though it has to be exactly the same triangle, but to start, it can be just a vector. Or yes. Sorry, I'm thinking out loud, but it's like somebody a bit mad. But I'm trying a new way. So I can use a line. I can use a vector. A line. You could. Oh, I've got the lines, so it's okay. So I've got everything I need here. So I will connect the endpoint here, and then from that polyline, or that one, curves, I will use the extreme points here. I think I can use that one, but I don't know precisely where they are. No, not from that vector. Sorry. I need that point. No, I need that point. Sorry, that one. And that one is there. So maybe a bit messy at the beginning, but I will solve it in the end. Up. So let's try. You see the vector is always drawn from the origin, so I don't really see if it works or not. So what will be doing is creating a line, and the line is just to check if I'm okay. If I'm not okay, I will see it easily. So it's tilted, so I've got to shift list again, but we saw it before. And which list am I going to shift? I will check if I take this one point, is it going to be better? No, yeah. So I don't need to shift. Okay, so I know that by taking this point, connecting here and there, I've got the right vectors to move this point. So I will move now that point up following this vector. Move. Move. Up. Okay. Geometry, it's going to be this middle point. The vector is going to be that one. And now it's totally symmetrical. So now I just have to connect my points, and it's done. It's nearly finished. Not really, but close to be finished. Not really close to be finished, but polygon. No, it's not polygon. It's polyline. Just polyline. Okay, sorry. Up. Polyline here. Closed. And then I can connect my points. So I need lines. Okay, geometry moves. So here it's going to be my endpoints. And now I've got to find which point. So you understand that I need that one and that one. So they must be hidden somewhere. This is it. There is a new addition, which I like very much. I used it very much. It's the relay. Okay, and here. Okay. This is good. And now what I'm going to do is shift list. Go here, my list. Shift 1. And there. Then I just have to hide what is not necessary to see, which is, so this one I need to see. That one, for now, I need to see. That one, I don't want to see because it's and that one I don't want to see. Okay, and now you can see the structure growing up. And what I got to do is to repeat the same process over and over again, and then in the end I will have the structure. I can hide some points. Not maybe not just right now, but so what I've got to check, because I've been going a bit fast, if I don't have double lines. So in my geometry, I always got to check which number. I got 10. Oops. 10 is okay, because sometimes in this process, I could have double lines or double points and so on, and make some errors when I try then to create the surfaces. Then it creates odd things. But doing this way, you see, and then it's repeating the process. What is very fascinating is by repeating the process, we will have, in the end, the dome created. And then we just change, for instance, the number of sides or the size of the first polygon, and it will change the overall shape. This is all. It's like Calatrava. It's kind of magical to see the result. So again, I can really copy and paste in fact, because it's then the same process of exploding, and then starting from the middle point, having the vector move, creating the lines, and it goes again. For each level, it will be the same. So let's try.
If you probably create a group and then copy a group.
Yes, usually that's what I do. In this example, I've got groups, as you can see, corresponding to each. I thought it was I thought it was named, but when I tried the first time, it was named like level 1, level 2, level 3, and so on and so forth. I think I made it more complicated the last time. Oh, it's basically the same. Yes, and then creating the face, it has to be, we have to identify 4 points to create a surface, and then to have the final shape. But where am I? Yeah. So here I can explode. I like to copy paste, but sometimes it creates things that I spend some time reconnecting the right things when it's not super clear. So maybe sometimes it's easier to redraw everything than copy pasting. You know, because my vectors they go kind of very weird way.
You can try Control Z. It's not fully finished, but it may work.
Is it working? No, it's not.
No, it isn't. Sometimes it works.
Yeah. No, but I can erase and just restart and explode. And the second layer is going to be exactly the same. The curve, then I need the midpoint. Okay, then I will create the line, and it's going to be also the vectors. So from that midpoint to this one where it's going to be this one step under. It's not this one. Should be that one. And that one is that one. Come on. Right. I'm gonna check if it's right. Nope. That's a good one. So it must be fine. Yes, this one. Yeah, it has to be shifted. Okay, and then same story. Tools, vector, 2 points. That one here.
Your muscle memory, you still don't want
Yeah.
to connect to the center of the port.
Okay, yeah, it's okay. Move. Okay, so move again. Here, geometry. So this is this that I want to move along this vector. Okay, so I've got my next level, and it's again polyline. Maybe we can do a competition to find the best way to, or the easiest way to. But I didn't find a better way to do that. It's I think it's the only way to do it. Maybe I don't know. Explode, so hide, polyline, hide, and then I will have to create my triangles. This I don't need. Hide, and same. So this and the point. This one, the standard one. It's that one, yeah.
Another thing that you probably are not aware, you can actually click on the node and drag it to the edge of the screen, and it will be moving your canvas.
Ah, okay. So I was searching that because yeah.
Although maybe it's too slow.
No. Maybe I wasn't too close enough from the edge because I was trying to, and
If you do it in the opposite direction, though, since the viewport is in the way, you need to drag your mouse still to the end. Keep dragging your mouse. Yeah.
oh yeah, very good. I learned a lot today. Just I put my shift.
So you always try to drag it from top and bring it from the top panel.
No, usually I write the name. When I explain, I drag it from the top because I know students usually they like to know precisely where are the elements. But when I'm working for myself, I just double click, and I type the name.
One recent feature, although I realized it could have been irritating for you because when you failed to connect, when you drag from a port and then release, it will open the chooser, this menu, search menu, and it's already filtered from what you can connect.
Oh yeah. Yeah, I was wondering what was in this panel. Okay, that's very good.
So it's already narrowing down in the options.
Yeah. That's clear. This is super. The interface is very easy to get. So I don't know if I go to the very end of the process, but it's always the same, repeating the same process. Try to hide the vectors because we create a kind of strange things in the middle. Shift and vector. So you can see the structure now as it could be. I could hide the points to make it more clear, but we see that little by little, the shape is creating by itself. And then it goes to the tip like that. And you can find these very nice curves that also creates an optical illusion. And what I would like to see, this I didn't succeed to see if it's how is it possible. I don't know if it's possible. Maybe you'll tell me to have a kind of repeating pattern, saying that we've got this, for instance, this group as a pattern. Because it does always the same, and then we connect the next one to the next one, and so on. And how it would be possible to say, repeat for me X time this pattern.
Yeah, the loops are not as possible.
Yeah. I don't know how. This is not my field of knowledge thing. Knowing that if it's possible to do it, or how hard is it to do that.
There's a similar method in Grasshopper also, where you can
Yeah, it's the
and
same.
combine it in the form of a node.
Yeah, I checked in Grasshopper, but it's the same question, and same way I don't know how to do that. I don't even know if it's possible.
In Grasshopper, you can do loops using a plugin or scripting.
Yeah.
Here, like we have the BeeGraphy plugin manager, so it's possible to do it using code, I guess. I don't know. I don't
Uh-huh.
know if our guys tried, but it's like creating a plugin is a whole process that one needs to, like, there's no scripting node at the moment in BeeGraphy.
Yeah, that's a very interesting question. Because it also links to security questions, I believe, that using scripts, because the time that you control every line of code that it's secure, but if it's open to something else, then it could be more dangerous for an online site. I don't know.
Yeah, hopefully our CTO will find a way to solve those issues.
Okay. Is it good enough, or do you want to see
Yeah,
more?
I think it's probably good. We can stop here and maybe let our users explore it and try to recreate it and finish it. Maybe share on Discord.
Yeah, it would be nice. I would really love to see the results. For this pavilion, as I said, there is a tutorial. My website, so it's easier to recreate eventually. There is a step-by-step tutorial where everything is explained. And I think it's very close to the way I've done it today. Oh, there are some drawings to explain the way to do it. The difference may be that I was creating the shapes along the way, because it was easier to find out where the points were along the way. So in this tutorial, if you use it, you see, so you can explain the images and see what has been used.
I have a question here. The panels that we are making are flat or not?
They are flat, always flat.
But their points are in different plane, I believe, right?
Yeah, but this is the trick for this architecture. It has to be flat, and this is why the creation process goes this way, because each step, a triangle of obviously it's flat because
It's flat.
triangles, yeah, they had to be flat. But for those one, they've got to be flat too, and that's why I'm using the vector to be sure that this is on a straight line and still remains flat, and it has to be flat so that it curves from time to time. And
Do you think there will be a gap in between two diamonds when the curvature is changing?
no,
Will there be a gap?
No, there won't be gap. And this is also the magic of it, is by creating this way, as I'm using the same points, there's no gaps. And as it is flat, there is no gaps. I think. I hope.
I believe if you see the image that was shown in the original image that you were trying to recreate, right? Not this one, the dome which was in the photograph.
This is AI rendering. I can find the real one.
Yeah, this one. Do you think, the surface level glass has a different angle than the frame? The upper part of the glass is basically slightly tilted, and the lower part is, protruding out. coming up slightly. Do you think it is the case here?
I'm not sure.
Okay.
Yeah, I would say no, but I'm not
It's
sure.
interesting.
Yeah. Because this is a really piece of work. It's like, but this is something we can explore when it's drawn,
Mhm.
to see the freedom that you have building this. I know that a friend of mine tried to build a similar one, but
Mhm.
he drew it with the the normal way, I would say. I don't know. There are some drawings trying to show the layout of it, how it has been done, and in fact, it's
Mhm.
super complicated. To get the shape. Um, I know that I found. I think it's on my website. Yeah. If I go back to my website, I will show you the layout, the basic layout that was used before, or said to be
Sure.
used before. Um,
That's good.
oh, I thought I put it. I forgot to put it. And you've got a very complicated with projections from the top, from the sides, and so on to get the shape. And I know that a friend of mine tried to build a similar drawings and using those projections, and he it was really that's funny. It was for me. It was funny. By that, it's true. Then you've got all the shapes, and then you can put it on the ground, and you can have all dimensions very precisely. Uh, but still, computer is not construction, so you can have also some issues during the construction process.
Yeah.
But what we can do, because from BeeGraphy you can print, and it could be interesting to go to the end of the process and to print some parts and then try to rebuild it from in reality.
Yeah. Surely it can be 3D printed. We have this
Yeah.
scale node.
Yeah. This is or just cut in papers, then flatten everything and print it on a cardboard or with the laser, to the cutting, and then try to rebuild it and check if we've got those kind of issues, small gaps that are not very visible, but in the end, when you've got the real object, then you can check if you've got gaps on this is something we could do.
Yeah.
Mm.
There is a node in Grasshopper which tests the planarity of surface, whether a surface is planar or not. So it basically evaluates.
Yeah.
Not in Grasshopper, it's in Rhino itself, I think.
But there
Evaluates.
I'm very confident that it is totally flat because the way it is built, it has to be flat. And when I'm
Yeah.
using the four-node surface, I think that the surface from 4 points doesn't accept to have a non-flat surface. I think it doesn't work in BeeGraphy. If it's not on the same plane, I think you cannot get a surface from 4 nodes. It was a way for me to check it. Using 4 points, and then you say, this is much better. You don't see what I'm doing.
No, I mean, I think you can show the other tab that you are about to say.
Yeah, no, because I was trying to check about the flatness question. Yeah, because surface 4 points, but learning can tell. But I think it's totally impossible to have one surface if those 4 points are not on the same plane.
Surface 4 point actually doesn't create, I mean, it's not necessary that it will always create a planar surface. It can create, I mean, a doubly curved surface.
Do you
So-
think so? Yeah.
Yeah. In Grasshopper, I worked on a similar project where I have created these kind of panels.
Uh-huh.
And it's not dome, but it's, I mean, it's sort of a wavy surface.
Yeah.
So I encountered a similar problem over there because you cannot bend the glass. I mean, it has
That's
to
it.
be flat.
Yeah.
And the other metal sheet panels can be bent.
Yeah.
So there I realized that we will have to evaluate each and every curve to see, I mean, either it has to be triangle or it has to be flat for the glass to come.
Yeah.
So
Yeah.
there we used a surface 4 point and it was generating these doubly curved surface, like a bent surface.
Yeah.
So
But
we had to evaluate and, check every panel, whether it is flat or not. If it is not flat, then we had to level up all the panels.
wow, interesting. But I really think that in BeeGraphy it's not possible to have a double curved surface from 4 points. But I'm not totally sure. I will make some tests, but I think it's not possible. Because I really had some issues at the beginning to get the surface from that shape. As although I was pretty sure that it was flat. I will try to see if it's possible to get the workup surface. How can I do that quickly?
We can just put surface 4 point and assign 4 random points and see.
Cool. Okay, I explode.
Yeah, you can see there.
Dispatch.
Yes, it does create doubly curved surface.
Does it?
Yeah, I just checked. I think there is an easier way to test.
Factor. Okay, so let's try. So there I should have 1 point. There only 1, 2. And then a sum. Okay, so I got my 4 points. this is yes, you're right. It creates, so it's not a proof. I thought it wasn't possible, but yeah, you can have a double curve surface from.
Yeah.
So
Let's
it's
see a technical surface.
yeah.
And one approach could be to, create a line and then extrude it in, in a, like on 90-degree vector, or, 90-degree angle,
Yeah.
probably. So that could be one way to test the planarity of the surface,
Yeah,
because
sure.
then it will not create these doubly curved surface,
Yeah,
I
yeah,
believe.
yeah. Interesting. So I thought it wasn't working before because I had some, as I said, I had some issues to do that, and it had to be flat. But I know, in this process, as I follow a vector, then I'm pretty sure it's flat because it has to be flat, because by construction it is flat. And I tested also to make a symmetry of the triangle, and then it's flat again. So there I'm pretty sure. But it's right that using this component, this node,
Surface 4 point.
yeah, it's not a proof that it is flat. The construction process can be, but not this. This node. Yeah. Super interesting.
I mean, I have a theory, though I'm not sure whether it is correct or not. So the other theory is the frames are deeper, right? Like they are not line actually the way we are showing here. So in reality, the frames are deeper. They have some depth, and these panels which are coming on top of it, when they are tilting, this frame is basically mitigating the error gap that is happening in between two planes. Possibly, I mean, this is my theory. I'm not sure whether it is right or not. So that's why I was wondering. You see, I mean, there are panels where you see at some places there is these glasses are going deep inside these panels. I mean, these frames.
Yeah.
They're not on top of it.
Yeah. You're right. Yeah. Yeah. They might have had some issues to do that at that time. It's quite something.
And it's quite interesting, I think.
Yeah. I think it's very interesting when you're using those kind of tools like BeeGraphy to go to search in this kind of architecture to see whether you can parameterize or find a way that the construction process.
Great. So I believe it. And anyone has any question, feel free to ask in the chat box. We have also shared the Discord link where you can join, test, and share your results.
I suppose, yeah, everybody's got my contact, so I can be. You can write to me and ask some questions so that I can answer. I will do the tutorial for the Calatrava building too, so that it could be followed.
Yeah. And yes, this video will be uploaded on the BeeGraphy YouTube channel. So anyone who wants to revisit this whole exercise can probably check it over there.
And I
reminds me that we also have launched a bug reporting feature on the website. So you can directly report any bug or request a feature using the chatbot which is there on the website. And once you have shared the bug, you can also track the progress, whether it is in progress or it has been completed, right in the chat box itself. So there is a roadmap section in the website. Probably I can share the screen and quickly
Yeah.
show it to you once. Yeah.
I will stop sharing.
So I was just trying to create that Surface 4 point. But this is the chatbot which you can visit.
Oh yeah, yeah.
So we have a roadmap, we have messages. So if you'll go to messages,
Mhm.
you can probably attach a screenshot or just activate.
Yeah, the easiest is probably
I can simply copy paste the bug, whatever is there,
Okay.
and then I will mark it over here and send it. So I can also report a bug,
Mhm.
and once that is there, you can then view it in the roadmap. So it will appear over here. What are the planned feature requests that are there? So we just launched, so we do not have much as of now, but
Mm.
you'll be able to locate it, what are planned, what are in progress, and where
Okay.
what is the status of your particular feature request.
Mm.
Abhishek, I think like from messages or from home, there is a way just to directly click, report
Yeah,
an
just
issue,
report an issue.
and
Mhm.
it asks you to mark right there.
You can basically put all the marker and everything. Yeah. So that also takes a screenshot and you can just report an issue.
Yeah, and there is a feature request as well over there.
So now you will see the progress that is happening. The bug is been submitted, whether it is a progress.
Mm.
And once approved, it will appear in the roadmap as well. So that just wanted to share, because if you face any issue, I mean, anyone who is facing issue with BeeGraphy, they can probably report it directly.
That's very nice. That's very nice.
Yep.
Yeah. Super. Very good.
Great.
So
I
I think we can-
want to thank you, Laurent, for this workshop. It was quite interesting. Both models are quite nice. They look difficult, like when you just see it, but then once you start doing it, or once we see how you do it, turns out it's quite easy.
Mm.
Bruno thought it's probably more complex than the first one.
Yeah, yeah, it is. Yeah. It's like level 2. Mm.
Then let's call it a workshop and finish it. Thank you all very much for joining. Thank you, Laurent, for hosting it. And see you guys in our next workshop.